Hello, 1C class. This is lesson for tomorrow, March 25th. And we're going to learn 13.8, a dreamer. And I just want to say something first before the class. I noticed a lot of students hasn't even started, hasn't even watched much of the video yet. I just want to let you know that we have exam, okay? We will have exam when we go back to school, which is May, the first week of May. Very likely I probably won't test you on chapter 11 and 12, but I will test you on 13, 14, and 15. These are three chapters, very, very important. So please keep up the work. Okay, so for today's lesson, we're going to do 13.8, and this is a long lesson, so I may have to break into two parts. So 13.8, we learn about extreme value, okay? Extreme value, we learn that in 1A first. In 1A, we learn about two-dimension extreme value, okay? So we learn about local mass, local meaning, and saddle point, and all these are point together, all these together, and there's an absolute also, but we don't learn absolute until later on, okay? And so all the local mass, local meaning, saddle point, these all together we call the critical point. Here's a theorem. So there's a function z equal fxy. If there's a point AB, okay, it's a local mass or local meaning, then the positive derivative for that point, for this function, will equal 0. And positive for y is also equal to 0. This for x is for y, okay? Now, if you have local mass, local meaning, you're definitely going to have this situation, so this part is always true. But when you come back, okay, if you have this equal to 0, there's no guarantee this will be a local mass, local meaning. That's because we come to another critical point called the saddle point. For saddle point, okay, the derivative, the saddle point positive derivative is equal to 0. But this point is neither local mass nor local meaning. Okay, you can look at this graph. This for two-dimension graph, and we graphed this before in the previous class. So y equal x to the q. You can see this point is a saddle point, because if you stand right in this spot, look on your right hand side, you are on the lowest point. But if you look at the left side, you are in the highest point. So you are neither local mass nor local meaning. Okay, so that's for two dimension. For three dimension, it's like a saddle you ride on the horse. So if you stay on this position, you look at the left and right, and you're at the lowest point. But if you look at the front and the back, okay, the red one, look at the front and the back, and you are the highest point. So in this situation, this is also saddle. Most of the time, the saddle points usually occur at your origin, okay? Most of the time, but sometimes you can be occurring other points. So we learn how to test local mass, local meaning. To test local mass, local meaning, we use a test called the second derivative test. But before we do second derivative test, I want to do first derivative test first. Okay. The first derivative test is for what? So let's have z equal to fxy. The first derivative test is f of x equals 0, fy equals 0, and to find critical points. Okay? So the first derivative test, we are looking for critical points. The second derivative test, we are looking for what type of critical point do we have. Okay? The second derivative test is for types of critical points. And we use a d is for derivative, and the formula is d is equal to f double x f double y minus fxy squared. Last time the student asked me, okay, why do we need to learn the double derivative or mixed derivative? So this Besides, we're going to use in the future for some of the engineering courses. But for here, we use for our second derivative test, okay? This second derivative gives us three choices. First choice is when d is greater than 0, okay? And if d is greater than 0, and your f s double x is also greater than 0, and you're going to have a local meaning, okay? You concave up. If your fss less than 0, you're going to concave down. You're going to have a local max. And then your d is equal to 0. If d is equal to 0, you have no conclusion. Okay, and if you have no conclusion, then what do? You use the other method. Okay, use other method. And I show you. You can use like look at the graph like that, okay, or use the critical thinking. And for d is greater than 0, you're going to get a saddle point. So that's for the second derivative test. Now we're going to do a problem. And the first one we're going to do is number 18. We are given z is equal to negative 5x squared plus 4xy subtract y squared plus 16x plus 10. They said find the local max, local meaning, okay? So the first thing we should do is to find the critical point first. To find the critical point, we use the first derivative test. So you're going to go f of x, that's equal to negative 10x plus 4y plus 16. And then we set this equal to 0. But we couldn't solve yet because the x and y are two different variables. So we're going to get fy. Fy equal to 4x minus 2y equal to 0. To solve this system equation, okay, this one I probably don't need to solve it to you guys. You just need to solve y here. Y is equal to x, and then put it inside here, okay? And then eventually come out your xy equal to 8 and 16. The second step, you want to know what type of critical point this one is, okay? So we use a second derivative test. For second derivative test, we need to find f of xx first. And use this one, find f of xx, that would be negative 10. And fyy, that would be equal to negative 2, okay? And then fxy, or you can use the fyx, so you get the same answer because we know that x, y, yx, you get the same thing. So fxy, so to y, that would be 0 here, that would be 4. So d is equal to f of xx, fyy minus fxy squared. So that's equal to negative 10 times by negative 2 minus 4 squared. So that's equal to 20 minus 16 is equal to 4, which is greater than 0. If it's greater than 0, then you need to look at this one, okay? And because it's greater than 0 and f of xx equal to negative 10, which is less than 0, so that'll be concave down. Okay, so you're going to have a local max. So you're going to get a local max at 8 and 16. And then now you need to calculate what this local max is. What's the value for this local max? You know where it is, but what's the value for it? So you put this number back into here, okay? So put this A and 6 back into here. And then to calculate your Z is equal to save time, is equal to 74. So therefore your maximum value is 74, okay? The point is A, 16 and 74, 74. So this is like X, Y, Z. So that's how you do number 18. And so number 18 we get local max. Let's try the one. Other one's the point number 32. We are given fxy equal to 2xy minus 1/2 x4 plus y to the 4 and then plus 1. So again, first we're going to find critical point, okay? And for f of x equal to 2y and minus 1/2 times by 4x cubed and the rest is 0. So it's a 2y minus a 2x cubed. And then fy equal to 2x minus 1/4, same thing, 4x cubed, so it's equal to 2x minus 2y cubed. And we set this equal to 0. And we're going to solve the system equation, okay? So if you take out the first one here, okay, y is equal to x cubed. And you take out this one, x equal to y cubed. And put it inside here. So y is equal to y to the y cubed to the cube, okay? So that's equal y to the 9, all right? And then once you get y equal to 9, and we're going to solve this, okay? So y 9 minus y equal to 0. Take out the y, a minus 1 equal to 0. So y is equal to 0 is the first point. The y equal to 0, then x equal to 0. So you get 0, 0. And then for this one, we have a subtract 1 equal to 0, okay? And then now you're going to factor this, so y4 plus 1, y4 minus 1. That's never equal to 0. Look at this one, y squared plus 1, y squared minus 1 equal to 0. Again, this is never equal to 0. Continue here, y plus 1, y minus 1 equal to 0. So y is equal to 1, and then a negative 1, and then 1. Then you put it inside the x. Your x will become negative 1 also, negative 1, and then positive 1, and then 1. So you're going to get 3 possible critical points. So now I'm going to erase this one. So I keep my critical point here, okay? This is my possible critical point, but I want to know, what type of critical point are they. So I need to use the second derivative. So fxx, I erase the first one, so that the fx equal to 2y minus the 2x cubed, so f of xx is just equal to negative ax squared. And you can look at the note from earlier. And the fyy, it will just equal to, oh no, this is 6 here. Negative 6 squared. And then fyy is equal to negative 6y squared. Then f of xy is equal to 4. F of xy are equal to. Okay, fxy is equal to. And then now we're going to take the test. So negative 6x squared times by negative 6y squared, subtract 2 squared, which is 4. So it's equal to 36x squared y squared minus 4. And then now once we get to here, we need to decide what kind of critical point we're going to produce for this type, for these three. So 0, 0 first. Most of the time when we get 0, 0, very likely this will be a saddle point. But we are not sure, so we're going to test anyway. But we just think that this could happen. So d is equal to 0, negative 4, which is less than 0. It is saddle point. Okay, the saddle point is, you put a 0, 0 inside here, so the saddle point is 0, 0, 1. Okay, and then the second one is a negative 1 and negative 1. I put d here, a, that is a 36 minus a 4 greater than 0. And then f of xx equal to negative 6 less than 0. So that means that you're going to get a local max. The local max point be, you put a negative 1 inside, and I get 2. Okay, I put negative 1 here, I get 2 here. And then for 1, 1, well, it looks like I will get the same thing, because if you put it here, you also get d is equal to 36 subtract 4, also greater than 0. And your f of xx also equal negative 6 less than 0. And then another local max. So local max at the point 1, 1 also 2. So that's, so it looks like the picture will be like this. Okay, saddle point here, and then there's a 2 point, both are local max. Or this point on the other side, Okay. 1, 1, negative 1, negative 1. Yeah, quadrant 1 and quadrant 3. So that's for 32. And what happens if sometimes you will have problem that it cannot be detected by using this way. Then you have to use a critical thinking. Let's look at the next problem, number 38. Then we'll break the video into 2 parts, because the last 2 problems are very long. We are given fxy equal to x 2/3 plus y 2/3. Okay, so for this one, if I'm going first, I will do the same thing. I'm going to take the positivity first. So if I take the positive with respect to x, I will have 2/3 x negative 1/3, and that is 0, right? And I said this equals 0. Well, let's see, this one have no solution. Why is that? Because okay, well, it's impossible you're going to get 0 here, because you have the best you can do is a 1. Okay, you cannot do that. If you say, oh, multiply this on both sides, well, if you multiply on this side, then you're going to get 1 equal to 0. That's not true. Is that right? So no, that's not true. So therefore, you have no solution. If no solution, then you look at the original function here. Okay, because it produced no solution, right? No critical point at all. So you want to see, if I look at my function here, would that also give me the same conclusion? I look at here, okay? you can see that your x can be any number, okay? The smallest number you can get will be what? 0. So it looks like, because when you square it, everything will be what? Positive, right? So maybe 0, 0 could be a smallest number, okay? And if I get x is negative, I square it, I get the same positive number. If I take the, so let's say my x equal -1, okay? And then my -1 will equal to 1 plus 1 is equal to 2. Is that right? And then if I'm going to go x equal to 0, I get f0. I'm going to, x equal to -1, y equal to -1, sorry. Okay. I'm going to write this, okay? If I get -1, and then I will get 2. If I'm going to get 0, 0, I will get 0, 0, and I will get 0. Okay, if I'm going to go for 1 and 1, I would get f1, 1 equal to a 1 plus 1 is equal to 2. It looks like positive, negative, I will get the same thing, okay, because the square here. And this will be my possible lowest point I can find. So this is as for my absolute minimum at 0, 0, 0. Okay, so that is how you do this problem. So that's for number 38. So that will wrap up for the first part of the lesson, and then now I'm going to do my second part of it. Okay, make sure you guys follow up the homework, so don't be late with this. I will still need to exam you guys.